So the last problem in your handout, I gave you a little hint going in, which is that one of the math practices for AB calculus that I'm testing you on every time is, do you check that the hypothesis of a theorem holds before trying to apply the conclusion of the theorem? Well, that's your hint to help you zone in on what the error is in part B here. This is L'Hopital's trap. So if I have a function 1 minus cosine x over x plus x squared, you could use a table of values or a graph and find out that the actual limit is 0. You see that's printed in your book. So then my question here, where is the error in this application of L'Hopital's rule, which comes to the conclusion that the limit is 1/2? This work in part B is wrong. The answer to part A is correct. So we want to make sure we don't fall into this trap. Because to be honest, L'Hopital's rule is kind of cool. It can take a really complicated limit problem and turn it into something kind of easy to evaluate. So the trap is to get so into using L'Hopital's rule that you forget to check every time that L'Hopital's rule actually applies. So here's the original problem. I can check at this point. If I replace all my x's with 0, what's the result? So I'm going to do that here. That would be 1 minus cosine of 1 is, cosine of 0 is 1, divided by 0 plus 0 squared. And I do, in fact, end up with 0 over 0. So it's appropriate to apply L'Hopital's rule here. So I do that. I'm going to take the limit as x approaches 0 of the derivative of my 1 minus cosine x numerator is sine of x. The derivative of my denominator is 1 plus 2x. And if you got excited and just kept taking the derivative until you felt like stopping, you could do what happens here, which is to keep going and not stop and check. But notice here, if we actually stop and check at this point, the limit as x approaches 0 of sine of x over 1 plus 2x. When I replace my x's with 0, I'm going to get sine of 0 in the numerator, which is in fact 0. And in my denominator, 1 plus 2 times 0. So I end up with 0 over 1. So the correct limit is 0 over 1. I can actually evaluate it. 0 divided by 1 is 0. And if I don't notice that and I try to keep applying L'Hopital's rule, I can end up with an incorrect result. So don't fall into L'Hopital's trap.